Everyone. We are group number 5 and our project topic is pothole prediction. As we all know, asphalt is most common material used for constructing pavement surface due to its flexibility and durability. But over time, it's get deteriorated and there are a variety of factors such as rain, snow, traffic load which affects the pavement condition. All this results in the generation of potholes. So we have collected the data sets of 2016, 18 and 10, 20 which will govern the factors affecting the pothole generation. So we have collected the data and selected attributes such as PCI, IRI, cycles, precipitation, and highest load. That so that we can explore the attributes which incorporate the payment condition into a model. Also, we can save time and cost-effective scheduling of the road maintenance activities.
The objective of the project is to determine which attributes contribute the most to the number of potholes, as well as to develop a model for predicting the frequency of potholes for any given street in Montreal. The level of accuracy for each model will be checked to determine which of them apply the best to our problem. The correlation matrix will be used to determine the association between our selected attributes and the generation of potholes, and also providing us with their corresponding level of correlation.
We will be using the supervised technique for predicting the probability of developing potholes using the regression and classification model. That is, by using a regression model, we will be predicting the relative attributes that favor the pothole generation. And by classification, we will be identifying the pattern recognition. After framing the model, we need to validate it and need to check out the data is not overfitting. We will be using the cross-validation as it is one of the most favorable technique for testing out the accuracy of prediction.
When it comes to the datasets, we retrieved the road condition datasets, the traffic count, and the pothole repair datasets from the City of Montreal Open Data Portal. Note that these datasets were recorded for multiple years. As a result, we only kept the datasets with matching years, that is 2016, 2018, and 2020. Then we extracted the relevant information from each dataset using reverse geoprocessing to convert coordinates to addresses, but also by removing the duplicates using sums and weighted averages. These three datasets were merged together based on their common attribute, which was street name. To merge properly, we had to fix the street name inconsistencies, and then we used the fuzzy lookup option in Excel with a threshold of 0.95. Finally, the weather data from the Airport of Montreal was retrieved for the required years, and the number of freestyle cycles was derived from it. This weather data was added to the merged dataset to obtain the final dataset.
As seen in the EDA, the data show most Montreal roads have a PCI of 68, which is considered fair. The higher the pavement condition index, the better the road condition. As for the IRI, which is the surface roughness, the lower IRI, the better the road is. So for average of 4.2, we can consider the surface roughness of most Montreal roads to be reasonable. For the percentage of heavy vehicles, most Montreal roads have a low percentage of high vehicles. This graph shows the variation of number of potholes in a road with the variation of the PCI and the load. The size of the circle shows the number of potholes. As we can see, with high load, the higher the number of potholes, and low PCI, the higher the number of potholes. As seen, most of the data is concentrated in the bottom right of the graph between average PCI of 50 to 100 with low load.
As expected, our target attribute, potholes per kilometer, has correlation with average PCI, average IRI, highest load, average load, mean temperature, and it's worth mentioning that average PCI and average IRI has correlation with highest load, average load, and weather data. Next steps, we want to remove the outliers and finish our pre-processing and therefore come up with a better correlation. Then we will deploy several models including KNN, decision tree, and regression. Later we will train and test our models. We will check their performance and accuracy, and last but not least, we will find the best prediction model and deploy it.